Hello students, welcome to Deeksha Karnataka YouTube channel. Uh, today you guys have taken NEET exam, right? Isn't it? I hope you guys have done well. In this video, I'm going to discuss the answer key of the NEET 2024 physics exam. Okay, the paper set is T3. Okay, yeah. So let's analyze the paper. How was the paper, right? Uh, Here, the first one. How easy or difficult was the paper? Actually, if you compare, okay, the difficulty level was the paper is moderate to difficult. Okay, so many numerical calculations are involved. Okay, and then the second one, how many questions were easy and how many questions were difficult? Here easy questions are 10, 33 moderate questions or medium level question. Okay, and then 7 questions are difficult questions. Okay, and the third one, how much does an average student can expect? Here average students can expect around 60 to 70 marks, okay, out of 180. Yeah. And the fourth one, were there any out of syllabus questions? Yeah, here the question number 26, okay, only one question came from out of syllabus. Okay, question then 5, how was the paper in comparison to the last year? If you compare this year paper to the last year, the level of the question, I mean difficulty level is bit increased. Okay, yeah. Okay, so let's start. Question number 1, a tightly wound 100 turn coil of radius 10 centimeter carries a current of 7 ampere. The magnitude of the magnetic field at the center of the coil is, okay, they are asking magnitude of the magnetic field at the center of the coil, right? So current in the coil is 7 ampere, right? And number of turns is 100. So use this formula, B equal to mu naught Ni divided by 2R. Okay, mu naught is 4 pi into 10 to the power minus 7, N is 100, I is 7 ampere, and R is what is the value of R? The radius, right? So radius is 10 centimeter. Solve this, you will get 4.4 millitesla. Okay, 4.4 millitesla. So the correct option is 1. Okay, the correct option is 1. So let's see the second one. Match least one with least two. Okay, diamagnetic material, right? So here the diamagnetic material susceptibility, okay, they have given susceptibility values and the type of magnets, right? Okay, diamagnetic material, right? The susceptibility value of the diamagnetic material is much lesser than 1, right? So A belongs to 2, right? And then ferromagnetic material, B belongs to 3, right? And then C, that is the paramagnetic material, that is C belongs to 4, right? C belongs to 4 here. And then non-magnetic susceptibility value is 0. Yeah, correct. D belongs to 1. So the correct option is 3. Okay, correct option is 3. Okay, let's move on to the third question. A thermodynamic system is taken through the cycle ABCDA. The work done by the gas along the BC. Okay, work done by the gas along the BC. Here work done is P into dV, right? P into dV, isn't it? So the change in volume is 0, so work done is 0, right? So the correct option is 3. Okay, correct option is 3. Next question, question number 4. An unpolarized light beam strikes a glass surface at Brewster's angle, then, okay, let's check each option. Both the reflected and refracted light will be completely polarized. This one is wrong, right? Reflected ray is completely polarized, refracted ray is partially polarized. Option number 2, the reflected light will be completely polarized, correct, but the refracted light will be partially polarized. So the correct option is second. Okay, yeah. Third one, sorry, question number fifth one. In an ideal transformer, the turns ratio NP by NS equal to 1 by 2. The ratio VS by VP is equal to, direct question, right? Here VS by VP is equal to NS by NP, right? NP by NS is 1 by 2, so NS by NP is 2 by 1. So the ratio is 2:1. Okay, so the correct option is 4. Okay, correct option is 4. fourth one 2:1. Next question, question number 6. A logic circuit provides the output y as per the following table. Okay, so they have given the table. Here you have to check every option. Okay, so the correct option is 1. B, complement of B, right? Complementary of B. So the correct option is 1. You have to check every option. Okay, you will get the first answer or first option. Yeah. Question number 7. In a vernier caliper's n+1 divisions of vernier scale coincide with n divisions of main scale. If 1 MSD represents 0.1 millimeter, the vernier constant in centimeter is. So what is the meaning of vernier constant? The vernier constant is the ratio of the smallest division in the main scale to the number of divisions in the vernier scale. Okay, smallest division in the main scale, here vernier constant. Okay, smallest division in the main scale to the number of divisions in vernier scale. Okay, number of divisions in the vernier scale is n+1. What is the smallest division in the main scale? 0.1 millimeter. In centimeter, this will be 1/100, right? So vernier constant is 1/100 into n+1. Okay, so the correct option is 4. Correct option is 4. Okay, yeah. Question number 8. The maximum elongation of a steel wire of 1 meter length if the elastic limit. What is the meaning of elastic limit? Elastic limit is stress is directly proportional to strain, right? Of steel and its Young's modulus respectively are 8 into 10 to the power 8 Newton per meter square and 2 into 10 to the power 11 Newton per meter square is. Okay, so here what is elastic limit? Elastic limit is stress by strain, right? We know that Young's modulus is equal to F divided by A divided by L, delta L divided by L. That is F equal Y equal to F into L divided by A into delta L, right? So what is F by A? Here F by A is 8 into 10 to the power 8. Okay, F by A is 8 into 10 to the power 8, and then Y is Young's modulus, right? Young's modulus. Here you need to find maximum elongation in this string, that is delta L. So delta L is equal to FL divided by A into Y. So now substitute the values. Okay, here this is F by A, and then this is Y. Okay, and then L is 1 meter. So now substitute the values. You will get delta L is equal to 4 millimeter. Okay, 4 millimeter. So the correct option is 3. Okay, correct option is 3. Next question, question number 9. A horizontal force 10 Newton is applied to a block A as shown in the figure. The mass of the block A and B are 2 kg and 3 kg respectively. The blocks slide over a frictionless surface. The force exerted by the block A on block B, right? Okay, again this one is also direct question, right? So let us draw the free body diagram. So I will draw the free body diagram on this diagram only. Here N is the force acting on B by A, right? So let us find the acceleration of the whole system. So what is the acceleration of the whole system? A equal to applied force F, that is 10 Newton divided by mass of the whole system 5, which is equal to 2 meter per second square. Okay, acceleration of the system is 2 meter per second square. So acceleration of the block B is also 2 meter per second square, right? So now force on block B due to A is equal to mass of the block B, that is 3, into acceleration of the block B, that is 2. So which is equal to 6 Newton. So the correct option is A or 1. Okay, correct option is 1. 6 Newton. Okay, yeah. Next question, question number 10. If the monochromatic source in Young's double slit experiment is replaced by white light, then, okay, if we replace the monochromatic light with white light, central fringe will be white. Okay, central fringe will be bright. Okay, and then the first order fringes will be colorful. Okay, many colored. Okay, we will get few colored fringes. Okay, so there will be a central bright fringe, white fringe, correct, surrounded by a few colored fringes, right? Yeah, option 1 is the correct answer, right? Isn't it? 10th one is 1. Yeah, next one, question number 11. The graph which show the variation of 1 by lambda square and its kinetic energy E is, where lambda is de Broglie wavelength of a particle. Again, the simple one, right? Here, momentum of the particle P is equal to h divided by lambda, right? So lambda is equal to h divided by P, right? So we know that the kinetic energy K is equal to P square divided by 2m, right? So P equal to root of 2mk, right? So now lambda is equal to h divided by root of 2mk. So now take square root on both sides, we will get K is directly proportional to 1 by lambda square. Okay, K is directly proportional to 1 by lambda square, or E is directly proportional to 1 by lambda square. So the correct option is the second one. Okay, correct option is the second one. Understood? Second one. Yeah. Question number 12. If the following circuit, the given in the following circuit, the given capacitance between terminal A and B. Okay, we need to find equivalent capacitance, right? In the given circuit, the equivalent capacitance between A and B. So if you look at this circuit diagram, you can easily say this one is this balanced Wheatstone bridge, right? 2 into 2, 4, 2 into 2, 4, right? So this is balanced Wheatstone bridge. So now you can neglect the middle branch, right? So now 2 microfarad, these two are in series, then 2 microfarad, these two are in series, right? So now equivalent capacitance between these two is 1 microfarad, then these two is 1 microfarad, then these two are in parallel, right? 1 microfarad plus 1 microfarad, 2 microfarad. So the correct option is 3, okay, 2 microfarad. Understood? Yeah. Next one, question number 13. In the above diagram, a strong bar magnet is moving towards solenoid 2 from solenoid 1. The direction of the induced current in the solenoid 1 and that in solenoid 2 respectively are through the directions. Okay, so this one is again the easier question, right? Apply Lenz's law, you will get the answer 2. Okay, BA to DC, B and DC. Okay, yeah. Next one, question number 14. Consider the following statements A and B. Identify the correct answer. Okay, we need to identify the correct answer, right? Okay, yeah. A, for a solar cell, the IV characteristics lies in the 4th quadrant of the given graph. This one is correct, right? In solar cell, we will get the negative current. That is, here from the solar cell, we are getting the current, right? Isn't it? We are not using the battery. From the solar cell only, we are getting the current. So that's why we will get the negative current, right? Negative value of the current. So the first statement is correct, right? Second statement, in reverse biased PN junction diode, the current measured in microampere is due to majority charge carrier. Wrong, right? Due to minority charge carrier. So correct statement is A only, right? So correct statement is A, right? Here A is correct, B is incorrect. Yeah, the third one. The third option is correct. Okay? Yeah. Question number 15. A light ray enters through a right angled prism at point P with the angle of incidence 30 degree, as shown in the figure. It travels through the prism parallel to the base BC and emerges along the face AC, the refractive index of the prism. Okay, so we need to find refractive index of the prism. Here you don't need to calculate. Okay, just look at the option. We know that refractive index of the prism is always greater than or equal to 1, right? So if you look at option 1, 2 and 3, you will get lesser than 1, the value lesser than 1. So the correct option is the fourth one. Okay, root 5 divided by 2. The fourth option is correct. Okay, Yeah. Question number 16. Given below are two statements. One is labeled as assertion and the other is labeled as reason. Okay. Assertion A. The potential V at any axial point 2 meter distance r from the center of the dipole moment vector P of magnitude 4 into 10 to the power minus 6 coulomb meter is 9 into 10 to the power 3. This statement is correct, that is assertion is correct. Why? We know that potential, electric potential due to electric dipole is P divided by 4 pi epsilon naught r square. Okay, so now substitute the given values, you will get 9 into 10 to the power 3 volt. Okay, reason V equal to plus or minus 2p divided by 4 pi epsilon naught r square. Anyway, this one is wrong, right? Isn't it? Actually, this has to be p divided by 4 pi epsilon naught r square, where r is the distance of any axial point situated at 2 meter from the center of the dipole. Okay, anyway, reason is wrong, assertion is correct. A is true, but r is false. Yeah. The first option is correct, right? First option is correct. Okay. Yeah. Question number 17. The moment of inertia of a thin rod about an axis passing through its midpoint and perpendicular to the rod is 2400 gram per centimeter square. The length of the 400 gram rod is nearly. Apply this formula, right? Okay. So this is the rod, right? This is the point where the axis is passing through. Okay. We need to find moment of inertia of the rod about this axis, right? So now moment of inertia of the rod about this axis is equal to m L square divided by 12. Okay, so they have given the value of I, okay, and m, you need to find the value of L. Okay, substitute the values, you will get 8.5 centimeter. Okay, L equal to 8.5 centimeter. So the correct option is 3, 8.5. Okay, correct option is 3. Yeah. Next one, question number 18. The terminal voltage of the battery whose EMF 10 volt and internal resistance 1 ohm when connected through an external resistance of 4 ohm as shown in the figure. We need to find the terminal voltage of the battery, right? So terminal voltage of the battery, the formula is V equal to EMF of the battery E minus I into R. Small r is internal resistance of the battery, right? That is 1 ohm, right? Okay, we don't know the value of I, right? Current flowing through the battery. So now we know that current flowing through the battery E is equal to EMF E divided by R plus R, right? So now substitute the expression of R to this equation, first equation. Okay, so now solve this, you will get V equal to 8 volt. Okay, V equal to 8 volt. So the correct option is 1. Understood? The correct option is 1. Question number 19. Match least one with least two. Okay, least one, spectral lines of hydrogen for transition from, okay, N2 to N1. And then least two wavelengths. Okay, so here option A, N2 equal to 3, that is third level to the second level. Okay, third level to the second level. Apply this formula. Okay, so 1 divided by lambda is equal to Rydberg constant R into 1 divided by N2 square. Okay, so n divided by N1 square minus n divided by N2 square. Apply this formula. Okay, R is 1.097. Okay, 1.097 into 10 to the power minus 7 per meter, right? So now apply this formula, you will get N2 equal to 3 to N1 equal to 1, right? So A matches with the first one, 656.3. Okay, and then the second one B, right? N2 equal to 4 to N1 equal to 2. So here B matches with the 4. Okay, and then third one N2 equal to 5 to N1 equal to 2. Here C matches with the second one, 434.1 nanometer, right? And then the last one N2 equal to 6 to N1 equal to 2. The last one matches with the first one. Okay, so the correct option is 4. Okay, correct option is 4. A belongs to 3, B belongs to 4, C belongs to 2, D belongs to 1. Yeah. Next question. Question number 20. If c is the velocity of the light in free space, the correct statements about photon among the following are, okay, the first statement, statement A, the energy of the photon is E equal to h nu. Correct, right? So A is correct. And then B, the velocity of the photon is c. Again, this is also correct, right? The momentum of the photon is P equal to h nu by c. Correct, right? Momentum of the photon is E by c. E is h into nu, so h nu by c. Correct. So statement C is correct. Statement D, in photon electron collision, both total energy and total momentum are conserved. This one is also correct, right? Statement D is correct. Let's check statement E. Photon possesses positive charge. Wrong, right? Isn't it? Photon does not have any charge, right? Isn't it? So the correct statements are A, B, C, D. So the correct option is fourth one, A, B, C, D only. Okay, yeah. Question number 21. So they have given one nucleus. Okay, so it has mass number 290 and atomic number 82. Now it undergoes alpha decay, right? Alpha decay. Now here mass number is 286 and then 80. Okay, so now the positron emission, right? So now this will be y equal to 286 and here you will get 286 and positron emission, right? So this will be 79, isn't it? Here beta minus decay, right? In beta minus decay, again this will be 286. Here x, z, right? 286 and 80. Now electron emission, right? Isn't it? Electron emission here x, y, okay? Y, this one is z, okay? This one is z, sorry. This one is z and then this one is p. Okay, so now it undergoes electron emission. Okay, the final product will have 286 mass number and then 81 atomic number. So the correct option is 2. Okay, correct option is 2. Next one, question number 22. At any instant of time t, the displacement of any particle is given by 2t minus 1 under the influence of force of 5 Newton. The value of the instantaneous power is, okay, they are asking instantaneous power, right? You know, right? Instantaneous power, P equal to dW by dt. Okay, W is work done, right? Rate of change of work done, isn't it? So work done is force into displacement, sorry, force dot displacement, isn't it? So power is equal to force dot displacement. Force is constant, so ds by dt, right? So P equal to F into S is given, right? 2t minus 1, isn't it? So what is the differentiation of 2t? 2. What is the differentiation of 1? 0. So 5 into 2 is 10 Newton, okay? So this is ds by dt, that is 2. So 5 into 2 is 10 Newton. So the correct option is 3. Okay, correct option is 3. Question number 23. The output Y of the given logic gate is similar output of AND or A. Okay. So this one is NAND gate and this one is NOR gate, right? Input is only one. So this is A bar and A bar. So now this is again the NOR gate, right? There are two inputs, A bar and A bar, right? So now the output will be Y equal to A bar plus B bar whole bar, right? So then this will be A bar dot B bar bar, that is A dot B. We know that output of the AND gate is A dot B, right? So the correct option is 2. Okay, correct option is 2. Next one, question number 24. The mass of a planet is 1/10th that of the Earth, and its diameter is half that of the Earth. The acceleration due to gravity on the planet, on that planet, right? Okay, so mass of the Earth, sorry, mass of the planet is 1/10th times mass of the Earth, right? And diameter of the planet is half that of the Earth, right? That is dE by 2, right? So therefore the radius of the planet is also half of the radius of the Earth, RE by 2, right? So we know that acceleration due to gravity G is equal to Gm divided by R square. So for Earth it is Ge, for planet it is Gp. So now write the expression for Earth and planet and then take the ratio Gp by Ge. The value of Ge is 9.8 meter per second square. Okay, so then you will get the value of Gp as 3.92 meter per second square. So the correct option is 2. Okay, yeah. Question number 25. Yeah, question number 25. Given below are two statements. Statement 1, atoms are electrically neutral as they contain equal number of positive and negative charges. Correct, right? Atoms are electrically neutral, right? So because they have equal number of negative and positive charges. Yeah, the statement 1 is correct. Statement 2, atoms of each element are stable and emit their characteristic spectrum. This one is also correct, right? Statement 2 is also correct. So statement 1, statement 2 both are correct. So the correct option is 3. Both statement 1 and 2 are correct. So correct option is 3. Okay. Question number 26. A wheel of a bullock cart is rolling on a level road as shown in the figure below. If its linear speed is v, okay, velocity of the center of mass of this wheel is v in the direction shown, which one of the following options is correct? P and Q are any highest and lowest points on the wheel respectively. Okay, so here we need to find velocity of the point P and velocity of the point Q. Velocity of the point Q is 0, right? Isn't it? Why? Because this is the direction of the omega into r. This is the direction of the v, right? Isn't it? So both are in opposite direction. Point Q has 0 velocity. So what about the point P? The point P has the velocity v plus omega into r, right? Okay, let's check each option. Option A, here option A, both the points P and Q move with the equal speed. No, wrong, right? Q has 0 speed, P has non-zero speed. Option 2, point P has 0 speed, wrong. Option 3, point P moves slower than point Q, wrong. Point P moves faster than point Q, yeah, correct. So the correct option is 4, right? Yeah. Question number 27. A particle moving with uniform speed in a circular path maintains constant velocity, wrong. Varying velocity, right? Option 2, varying velocity, correct. Varying acceleration, correct. So the correct option is 2. Okay, yeah. Question number 28. A thin flat circular disc of radius 4.5 centimeter is placed gently over a surface of water. If surface tension of water is 0.07 Newton per meter, then the excess force required to take it away from the surface, right? Okay, so here when you place the disc on the surface of the water, right? So there will be a force of surface tension, right? Isn't it? So the force of surface tension F is equal to surface tension S into the length, right? The length of the object. Here the length is the circumference of the disc, right? That is here that will be 2 pi r. Okay, radius of the disc is given, surface tension is also given. Okay, so now apply the values. Okay, given values, you will get 19.8 millinewton. Okay, F equal to 19.8 millinewton. So the correct option is 3. Next question, question number 29. A uniform magnetic field of 0.049 Tesla, a magnetic needle performs 20 complete oscillations in 5 seconds. So now what is the time period of the this needle? The time period of the needle will be t equal to 5 divided by 20. That is 1/4 second, right? Isn't it? So what is the meaning of time period? Time taken by the needle to complete one oscillation. Okay, yeah. The moment of inertia of the needle is 9.8 into 10 to the power minus 6 kg meter square. If the magnitude of the magnetic moment of the needle is x into 10 to the power minus 5 ampere meter square, then the value of x is. Again, the direct question, right? Use this formula. Time period of the needle t equal to 2 pi into root of I divided by m into b. So what is I? Moment of inertia of the needle. What is m? Magnetic moment of the needle. So magnetic moment, right? B is applied magnetic field. So now, and t is 1 by 4 second. Okay, we need to find m, right? Isn't it? That is the value of x, isn't it? So now solve this, you will get the value of x as 1280 pi square. Okay, so the correct option is 2. Correct option is 2. Next question, question number 30. Two bodies A and B of same mass undergo completely inelastic one-dimensional collision. The body A moves with the velocity v1, while body B body B is at rest before collision. The velocity of the system after collision is v2. The ratio v1 is to v2. Okay, they are asking where ratio v1 is to v2, right? So now apply conservation of momentum theorem. So what is the conservation of momentum theorem? Initial momentum equal to final momentum, right? So initial momentum is mass of the first body or body A, m, into velocity of the body A, v1, and before the collision, the body B is at rest, right? So initial momentum of the body B is 0. Next final momentum is m1 plus m2 into v2, right? M1 plus m2 is 2m, right? So now solve this, you will get v1 is to v2 as v1 is to v2 as 2 is to 1. Okay, the correct option is 4. Why it is m1 plus m2? Because it is completely inelastic collision. Yeah. Question number 31. If x equal to 5 sine of pi t plus pi by 3 meter represents the motion of a particle executing simple harmonic motion, the amplitude and time period of the motion respectively. Again, the simple one, right? We know that the general equation of the displacement of the particle when the particle executes simple harmonic motion is x equal to a sine omega t plus pi, right? Phi is phase difference, omega is angular frequency, a is amplitude. Yeah. So now compare, amplitude is 5 meter, okay, and omega is pi, right? So what is omega? 2 pi by t, right? 2 pi by t, which is equal to pi. So now pi will get cancelled, 2 equal to 2 second, t equal to 2 second, okay. Amplitude is 5 meter, time period is 2 seconds. So the correct option is 4. Question number 32. The quantities which have the same dimension as those of solid angle. So what is the dimension of the solid angle? It is dimensionless, right? Because it's angle, isn't it? Dimensionless. Strain and arc. No, arc has the dimension, right? Isn't it? That is the L. So first one is wrong. The second one, angular speed and stress. Again, angular speed and stress both have the dimensions, right? Isn't it? So option 2 is wrong. Option 3, strain and angle. Correct. Strain doesn't have any dimension. Angle doesn't have any dimension. So correct option is 3. Okay. Correct option is 3. Question number 33. A thin spherical shell is charged by some source. The potential difference between the 2 points C and P shown in the figure. Okay, we need to find potential difference between C and P. So this is the hollow sphere, right? So potential at the center of the sphere is same as potential on the surface of the sphere, right? So potential difference will be 0. That's it. So the correct option is 2. Okay. Question number 34. A bob is whirled in a horizontal plane by means of string with an initial speed of omega revolution per minute. The tension in the string is T. Okay, so this is the bob. I will draw the diagram here. Okay, so it is rotating on the plane, right? The radius is R. Okay, so now tension provides the centripetal force, right? So T equal to m omega square R. If speed becomes 2 omega, that is angular velocity becomes 2 omega or angular speed becomes 2 omega, while keeping the same radius, the tension in the string becomes, okay, now T dash is equal to 4m omega square R, right? So now T dash is equal to m omega square is T, omega square r is t. So this will be 4t. So the correct option is 4. Okay. Yeah. 35th. A wire of length L and resistance 100 ohm is divided into 10 equal parts. That is, each parts has the resistance R by 10, right? Because R is directly proportional to L. Here area is not changing, right? So R is directly proportional to L. That is, area of cross section is not changing. Okay. The first 5 parts are connected in series. Okay, first 5 parts are connected in series. So equivalent resistance will be R by 10 plus R by 10 plus R by 10 plus R by 10, right? So that will be R divided by 2, right? While the next 5 parts are connected in parallel. Okay, so next 5 parts are connected in parallel. So equivalent resistance will be R divided by 50, right? The two combinations are again connected in series. Okay, now two combinations are again connected in series. So this is R equivalent. The resistance of the final combination. Solve this, you will get R equivalent as 52 ohm. Okay, 52 ohm. So the correct option is 4. Yeah. Question number 36. The following graph represents the TV curve and ideal gas, where T is the temperature, V is the volume, at 3 pressures P1, P2 and P3 compared with those of Charles' law represented as dotted lines. Okay, so we know that Charles' law is T is directly proportional to V, temperature is directly proportional to the volume, right? And ideal gas is PV is equal to nRT, right? PV is equal to nRT. So P is equal to nRT divided by V, right? So the slope of TV graph gives us the pressure, right? So the slope of P1 curve is greater than P2 and slope of P2 curve is greater than P3, right? So now the pressure P1 is greater than P2 is greater than P3. So the correct option is 2. Okay, yeah. Question number 37. A parallel plate capacitor is charged by connecting it to a battery through a resistor. If I is the current in the circuit, then the gap between the plates, option 1, displacement current of magnitude equal to the I, correct, flows in a direction opposite to that of I, wrong. This one is wrong, right? In the same direction, displacement current and the current magnitude of I, okay, displacement current and the current, okay, current in the wire, both moves in the same direction. Okay, so first statement is wrong. Second statement, displacement current of magnitude greater than I, wrong. Third statement, there is no wrong. The fourth statement, displacement current of magnitude equal to I, correct, flows in the same direction as I, correct. So the fourth option is correct. Okay, yeah. Question number 38. The property which is not of an electromagnetic wave traveling in the free space is that? The first statement, okay, first option, they travel with the speed equal to 1 by, okay, this one is correct, right? Isn't it? Statement, the first statement is correct. So first option is wrong. Statement in the first option is correct, right? So first option is wrong. Second one, they originate from the charges moving with the uniform speed. This is wrong, right? This statement is wrong. The charge has to move with the varying speed, right? Or charge has to move with the acceleration, then only it can create the EM wave, isn't it? So the second option is correct. Third option, okay, anyway, second option is the correct answer, right? Isn't it? Third and fourth are correct statements. Yeah. Question number 39. Choose the correct circuit which can achieve bridge balance. Okay, so there is some error in this question. Okay, I think here this has to be 5 ohm. Okay, here this has to be 5 ohm. So 39, there is a question, sorry, there is an error in the question number 39. Okay. Question number 40. If the plates of a parallel plate capacitor connected to a battery are moved close to each other, then, okay, the charge stored in it increases. Yeah, correct, right? Isn't it? If you move the capacitor, okay, if capacitor move close to each other, the charge will be increases. Why? Because C, capacitance C is equal to epsilon naught A divided by D. So if two plates move close to each other, what happens? Capacitance, sorry, D will be decreases, right? If D decreases, capacitance will be increases, right? So the value of C increases. If C increases, Q will also be increases, right? The charge stored in this capacitor will be increases. Yeah, A is correct. B, the energy stored in it decreases. Wrong. Energy stored will also be increases. So statement B is wrong. Statement C, its capacitance increases. Correct. Statement D, the ratio of the charge to its potential remains same. No, the ratio of the charge to potential will be increases because charge is increasing, right? D, okay, D is done, right? This statement is correct. E, the product of charge and voltage increases. Okay, the product of charge and voltage will also be increases. Yeah, this is correct, right? Isn't it? If Q increases, then the product of Q and V will also be increases. So ACDE is the correct answer, right? Isn't it? The 40th one here, ACDE. Okay, the ratio of the charge to potential remains same. Ratio of the charge to potential, right? So this is the capacitance, right? See, if okay, D has to be correct, right? So but in the option 4 they have given only ACE, right? Actually option 4 is the correct answer, but they have omitted D, right? So actually the correct option is 4. Okay, yeah. Question number 41. A force defined by F equal to alpha t square plus beta t acts on a particle at a given time t. The factor which is dimensionless if alpha and beta are constants is. Okay, we need to find the correct option, right? Here you have to check every option. Okay, first find the dimension of alpha and then beta. You will get the this answer, alpha t divided by beta. Okay, so the fourth option is correct. First find dimension of the alpha and then dimension of the beta. That's it. Yeah. Question number 42. A metallic bar of Young's modulus 0.5 into 10 to the power 11 and a coefficient of linear thermal expansion 10 to the power minus 5 per coulomb, length 1 meter and area of cross section 10 to the power minus 3 meter square is heated from 0 degree Celsius to 100 degree Celsius without expansion or bending. Remember, this is a bit trickier one, right? So it heated from 0 degree Celsius to 100 degree Celsius without expansion or bending. The compressive force developed in it is. We know that Young's modulus Y equal to F into L divided by A into delta L, right? F into L divided by A into delta L. So now here Young's modulus is given, right? Isn't it? So what we need to find? We need to find the value of force, right? So now the force F is equal to A into delta L divided by A into delta L into Y divided by L. Okay. So now substitute the given values. Okay. Here you will get 50 into 10 to the power 3 Newton. Okay. 50 into 10 to the power 3 Newton. Okay. So because here delta L is equal to L into alpha into delta T, right? Alpha is given, delta T is 100 degrees Celsius, right? And then L is 1 meter and L will get cancelled. You will get the answer. Okay, F equal to 50 into 10 to the power 3 Newton. So fourth option is correct. Okay, yeah. Question number 43. A small telescope has an objective of focal length 140 centimeter, that is FO is equal to 140 centimeter, and an eyepiece of focal length 5 centimeter, that is FE is equal to 5 centimeter. The magnifying power of the telescope for viewing a distant object. So magnifying power of the telescope M is equal to FO by FE, right? FO by FE. So now FO is 140, right? FE is 5, isn't it? FE is 5. So 5 2s are 10, right? So then 5 8s are. So 28 is the correct answer. Okay. 28 is the correct answer. So option 4 is correct. Understood? Option 4 is correct. Question number 44. An iron bar of length L has magnetic moment M. It is bent at the middle of its length such that the two arms make an angle 60 degree with each other, the magnetic moment of this new magnet is. We know that magnetic moment M, here magnetic moment M is equal to pole strength M into the distance between the two poles, that is L. Okay, distance between the two poles, that is L or 2L. Okay, in some book they have given 2L. Okay, yeah. So now it is bent like this, right? 30 degree and 30 degree, total 60 degree, right? So now what is the distance between these two poles? That will be L by 2. Okay, so now find the magnetic moment, new magnetic moment, then take the ratio, you will get M dash as M by 2. Okay, so the correct option is 4. Okay, correct option is 4. Question number 45. A 10 microfarad capacitor is connected to a 210 volt, okay, 210 volt 50 hertz AC source. Okay, so what is 210 volt? 210 volt is DC voltage or AC voltage? AC voltage, right? That is VRMS. And F is 50 hertz. As shown in the figure, the peak current in the circuit is nearly. Okay, we need to find peak current in the circuit, right? Isn't it? Okay, so here we know that Vrms is equal to Irms into XC, right? So now Vrms is V0. Okay, Vrms is anyway, it is given, right? Isn't it? So we need to find peak current. So Irms is I0 divided by root 2, right? So now Vrms into root 2 is equal to I0 into 1 divided by omega c, right? Omega is 2 pi f. So now I0 is equal to Vrms into root 2 into omega. Omega is 2 pi f, right? 2 pi f into c. Okay, so now solve this, you will get peak current as 0.93 ampere. So the correct option is the fourth one. Okay, correct option is the fourth one. And next, 46. Two heaters A and B have power rating of 1 kilowatt and 2 kilowatt respectively. Those two are first connected in series and then in parallel to a fixed power source. The ratio of power outputs for these two cases. Simple, right? Here these two are connected in series, right? Yeah. So now these two are connected in series, isn't it? So what is the output power? Here we know that power is inversely proportional to R, right? Or R is inversely proportional to power, isn't it? So now initially these two are connected in series. So now here output power will be 1 by P output equal to 1 by P1 plus 1 by P2. Okay. So then these two heaters connected in parallel, right? So in parallel output power will be so this is P0 dash is equal to P1 plus P2. Okay, so then take the ratio, you will get 2:9. So the correct option is fourth one. Okay, yeah. Question number 47. The velocity v and time t plot of the motion of the body is shown in the figure. The acceleration a versus time t graph that best suits this motion is. Don't look at the option. Okay, just draw the diagram, a versus t graph. So now here a versus t graph of v versus t, right? So here the time is not from the 0, right? Isn't it? Okay, so now here from this point to this point the slope is constant, right? That is, the velocity is changing continuously, right? So velocity is changing continuously, so acceleration is constant because slope is constant, isn't it? So acceleration is constant. Okay, so this is the point, from this point to this point, or from this time, okay, t1 to t2, the acceleration is constant, right? And then Acceleration is 0 because velocity is not changing, right? Acceleration is 0. Okay, then acceleration is 0. And then velocity is decreasing continuously, right? So velocity is decreasing continuously. So there is a retardation, right? Retardation. This is the retardation from T3 to T4. Okay, T3 to T4. So this is the graph. So the correct graph is in option 1, right? So option 1 is the correct answer. Okay, option 1 is the correct answer. Question number 48. If the mass of the bob in a simple pendulum is increased to thrice its original mass, okay, anyway, the time period of the simple pendulum does not depend on the mass, right? Okay, and its length is made half its original length, then the new time period of oscillation is x by 2 times its original time period. Then the value of x is, the value of x is here root 2. Okay, you will get the option correct here. Option 4 is the correct option. Okay, so how we will get root 2? Here we know that time period of the oscillation t is equal to 2 pi into root of L by G, time period of the simple pendulum, right? It does not depend on the mass, right? But it depends on the length. Now length becomes half, right? So now the second or new time period t dash is equal to 2 pi into root of L by 2G, right? So now t dash is equal to t divided by root 2, right? T divided by root 2. So t dash is x by 2 times t, right? T dash is x by 2 times t, then find the value of x, you will get root 2. So the correct option is 4. Okay. Question number 49. The minimum energy required to launch the satellite of mass m from the surface of Earth of mass capital M and radius r in a circular orbit at an altitude of 2r from the surface of the Earth is. Okay, so here this is the Earth, here this is the satellite. So we need to launch the satellite, right? So this is another orbit. Okay, distance between center of the Earth to the orbit is 3r, right? From the surface of the Earth to the orbit is 2r, isn't it? So we need to find minimum energy should be given to this. What is the minimum energy should be given to the satellite so that it can reach the this orbit, right? Or orbit of radius 3r, isn't it? So apply conservation of energy theorem. So energy of the satellite when it is on the surface of the Earth. So what is the energy? Energy is potential energy, right? The potential energy is minus gmm divided by r plus kinetic energy given to the satellite k equal to, that is the minimum energy given to the satellite. Okay, we need to find the value of k, which is equal to then here potential energy of this orbit. Okay, potential energy when the satellite comes in this orbit, right? So that will be minus gmm divided by what is the distance here? This will be 3r, right? 3r plus, so when the satellite comes to this orbit, what happens? It will start to rotate, right? Or it will start to move along this orbit, isn't it? So the kinetic energy of the satellite, half m into v naught square. V naught is orbital velocity, right? Orbital velocity will be gm divided by r. So now solve this, you will get 5 gmm divided by 6r. Okay, so the correct option is 3. Okay, solve this equation, you will get k as 5 gmm divided by 6r. Understood? Yeah. And then the last one, question number 50. Yeah, okay. Question number 50. A sheet is placed on a horizontal surface in front of a strong magnetic pole. A force F is needed to hold the sheet there if it is magnetic. Correct. Hold the sheet there if it is non-magnetic. Wrong. Option C, move the sheet away from the pole with the uniform velocity if it is conducting. Yeah, correct. And move the sheet away from the pole with the uniform velocity if it is both non-conducting and non-polar. Wrong. So the correct statements are A and C. So the correct option is 4. Correct option is 4. Okay. Yeah, that's it. Okay, so check the answer key. Okay, check the answer key with your answers. Okay, you will get the idea how much you will get the how much you can score in this NEET exam. Okay, yeah, thank you so much for watching this video. If you love this video, please like and share, and if you want to watch more such videos, please subscribe. Thank you.